This class will discuss about the colloids. What is the meaning of colloid? Let me see discuss. In Greek, kolla means what? Glue it is. Right? So idos means what? Same like. So glue-like compounds. Glue-like compounds can be taken as what? Colloids, isn't it? The name colloid taken from glue-like compound colloids. Here. You observe this one. These particles are nothing but snow particles which are coming down here are nothing but called colloidal particles. Now, colloid is not a substance, but it is a state of substance which depends upon the molecular size. That means when you change the size of the molecule, it may convert into colloid. The solution may convert into colloid. Colloid may convert into suspension. So colloid is not at all a substance. It is not a substance. It is only depends upon the size of the molecule. Any substance can be converted into colloid based upon their molecular size. Next, what would be the molecular size of the colloids? Generally, if you observe nanometer, 1 nanometer, that is equal to 10 to the power of minus 9 meter, to or 10 to the power of minus 6 meter. This size, isn't it, which indicates that is a colloid molecule. Present the size definitely for what? Colloid particles. Next, colloidal particles have enormous surface area per unit mass because of their size. Because of their size, what happened? They have large surface area per unit mass. Consider a cube with 1 centimeter side. This is a cube with 1 centimeter side. Can anyone tell what would be the surface area for this cube? The surface area of the cube will be 6 centimeters square. Right? Now, to get colloidal particle, you have to divide this cube into 10 to the power of 12 cubes. Then, what will be the surface area of the cube particles? In that case, the volume of big cube is 1 centimeter cube. Volume of the small cube 1 by 10 to the power of 12 centimeter cube, that is equal to 10 to the power of minus 12 centimeter cube. The side of the small cube will be 10 to the power of minus 4 centimeter, and the total surface area will be what? 60,000 or 60,000 centimeters square. So in this way, what happened? The surface area you are getting what? So this is not important for us in examination. Let me take here. Thomas Graham observed that sugar, urea, sodium chloride, when they pass through the membrane, other like glue, gelatin did not. That means what happened? He has taken a membrane. He has taken. This is a membrane, a cell membrane, which has some porous nature. Which has some porous nature. Now, when you pass sugar into this, what happened? Sugar is passing, urea is passing, sodium chlorides are passing through what? Membrane. But when you pass glue, gelatin into this cell membrane, they are not passing through it. They are remaining on the surface only. Okay? They are remaining on the surface. Which one? Glue and the gelatin. They are not passing through what? Cell membrane here. Which one passing? Sugar, urea, sodium chloride. They are passing through this cell membrane. Now, based on this, what we can say here? A colloidal solution is a heterogeneous solution. Heterogeneous system here. The solution is homogeneous, but colloidal solution is what? Heterogeneous in nature. in which one substance is dispersed into large particles in another substance. So the substance which is dispersing is called dispersed phase, in which the dispersion is taking place. That medium is called dispersion medium. Just like solute and solvent, just like adsorbent, adsorbate, here also we are having dispersion phase, dispersion medium. This will be always large quantity. This will be always what? Small quantity. And generally, these dispersion phases will act as colloidal particles. They are what? Colloidal particles. And this can act as what? Medium, solvent. They can act as a solvent. Just like solute and solvent, the colloidal particles can act as a solute like that. They can be called as dispersion phase. Now, what is heterogeneous system if you observe here? If you have two phases, okay, then they are called heterogeneous system. If you have one phase, uniform phase, they are called homogeneous system. For example, if you observe what happened, taken here, air, for example, we'll take air, right? In this air, you are having dust particles you are having. Now, this air is in the form of gaseous state, the dust particles in the form of solid state. Now, these two are what? Two phase systems. Now, this comes under where in the heterogeneous system, right? So, for example, if you observe here, milk, milk contains what actually? Fat in fat and water. Okay. Fat is actually solid, water is actually liquid. But generally, milk is actually liquid solution only. But you can easily separate this. Separation is what? Very easy. So we'll discuss all these examples later. Now we'll see what is dispersion phase here. Dispersion phase means what? The phase in which the solution, the substance exists as a colloidal particle. I told you already dispersion phase means colloidal particles which will disperse into the solvent. Okay. So generally colloidal particles can be called as dispersion phase. So what is dispersion medium? This is the phase in which the colloidal particles are dispersed. Whatever the colloidal particles are dispersed. That means a solvent it is. For example, if you observe, dust particles are dispersed in air. Now, dust particles can be taken as what? Colloidal particles. Whereas air can be taken as what? Dispersion medium. That means a dispersion medium, DM. This one will be DM. When you observe what happens, salt with water. Salt with water is a colloidal solution. Let me see this one. Whether salt with water, salt solution is colloidal or not. Let me see this one. So if you observe salt in water, isn't it? If it's just true solution, because when you add salt in the water, you cannot separate the salt and the water. And if you view through a naked eye, salt and the water uniformly they're having same phase. They don't have the different phases because in the colloidal system you should have heterogeneous system. But once mix salt with water, it convert into homogeneous system. It convert into homogeneous means single phase it exists. But when you consider salt with water, it is getting what? Single phase. Therefore, definitely salt with water, NaCl in the water, salt with water, definitely taken as what? True solution, but not what? Colloidal solution. Milk, if you observe what happens, is milk is a colloid form or not? Let me discuss about milk. Now, milk carries what? Milk contains what? Fat particles, isn't it? In water. Okay. Milk contains what? Fat particles in water. This is a milk which can be taken as what? Colloid. Okay. We can also call as emulsion. Emulsion also we can take for this one, but emulsion is not there in the syllabus. You can leave this. Milk is an example for the colloid in which fat particles present in what? Water. They present in the water. And this fat particle size is resembles with what actually 10 to the power of minus 9 to 10 to the power of minus 6 meters. It resembles to what actually colloidal particles. Then milk definitely comes under what actually. Definitely it is a colloidal solution. Next, if you observe what happens, sand with water. Sand with water. See, sand with water, if you observe what happens, it's a purely suspension. So if you add some sand in the water, it will come down. It will come down. It will reside at what bottom here. It's a suspension actually. It is not at all colloidal. It's a suspension actually. Suspension means which give precipitation. Okay? So both are solvent and the solute. Dispersion phase, dispersion medium, both are completely separable here. So you can easily distinguish that one. So suspensions are not at all colloidal. So three types of solutions you are seeing here. One is true solution, other is colloid, last one is the suspensions. So they depend upon the size actually. Which one you have to call suspension, which one we have to call colloid, and which one you have to call true solution. That depend upon the size. If you have something what happen, right on this. It depends upon the different size of the particles present in the dispersion phase. So the size of the dispersion phase decide whether it is a colloid, true solution, or suspension. Let me discuss this one. Now, first of all, we see what happened whenever the size is less than 1 nanometer. Okay, whenever the size is what? Less than 1 nanometer. The size what happened? Less than 1 nanometer. Less than 1 nanometer. That means less than something like the size of the particle dispersed space between 10 to the power of minus 10 to 10 to the power of minus 10. That means lesser than 1 nanometer. Then this is called what? True solution. For example, salt solutions in which the particle size is what? Less than 1 nanometer. The size of the initial particle is less than 1 nanometer in the solution. Therefore, they are called true solutions. Now, if you have, isn't it? This is an example for this one, salt with water. When you add some salt with water, we got like that. Now we see what milk here. Milk is a colloidal solution. In which what happened? The size, already I told you, the size of the dispersion phase particle, colloidal particles are between 1 nanometer, 10 to the power of minus 9 to 10 to the power of minus 6 it is. Isn't it? Something around micrometer like that. Nanometer to micrometer. 10 to the power of minus 9 to minus 6 meter. Then this is called what? Colloidal solution. So depend upon the size of the particle we can see. And finally what happened is the size is what? More than 10 to the power of minus 6 meter. So this is the thing. More than 10 to the power of minus 6 meter. Then they are called what? Suspensions. In this, the size of the particle, the size of the dispersion phase, the size of the colloidal particle, size of the dispersion phase is what actually what? More. That is more than 10 to the power of minus 6. Then they comes under the suspensions. So we can classify true solution, colloidal solution, and suspension based upon the size of the dispersion phase. Here, less than 1 nanometer. Here from 1 nanometer, 10 to the power of minus 9 to 10 to the power of minus 6. Here more than 10 to the power of minus 6 meters. This is what about solutions, colloids, and suspension. Let me see some questions on this. Colloids have the molecular size range between. Definitely the answer will be what? 10 to the power of minus 9 meter to 10 to the power of minus 6 meters. Colloids are homogeneous, heterogeneous, both are none. So generally solutions will be homogeneous. Two solutions will be homogeneous. And colloids and suspensions, both will be what? Heterogeneous. Even not only colloids, even suspensions also comes under heterogeneous systems. To observe the classification of the colloids. Classification of the colloids is very important. On which base you are classifying the colloids here? Based on the physical state. Based on the physical state. Now the physical state of the dispersion phase, physical phase of the dispersion medium, if you observe, on that we can classify the colloids here. Now this is a second classification. We'll discuss later. Nature of interaction between the dispersion phase and dispersion medium. What type of interactions are there? Whether they are having what? Active interactions or repulsive interactions. Based upon that also we can classify the colloids here. And finally we can also classify the colloids by the type of the particles. What type of particles are there? The type of the particles of the dispersion phase also we can. Let me see the first one based on the physical state of dispersion medium and dispersion, isn't it? Phase, right? Dispersion phase may solid, liquid or gas. Dispersion medium may be also what happened, solid, liquid or gas. So dispersion phase may be gas, liquid or solid. Dispersion medium may be gas, liquid or solid. Now let me discuss about here. There are 8 types of colloid systems are there. But solutions, two solutions are how many types? 9 types are there. That we discussed in the solution chapter. But two solutions are 9 types. That means what happened? Gas in gas, gas in liquid, gas in solid. Similarly, liquid in liquid, liquid in gas, liquid in solid, and like solid in solid, solid in liquid, solid in gas. 9 types are there. Each one two solutions. But colloids are 8 types only. Except gas in gas, except gas in gas, remaining all we can get. Remaining all we can write. 8 type of colloids we can write all, right? Next, first of all, we'll see dispersion phase is solid and dispersion medium is also solid. In this case, what type of colloid we can call this one? Example, if I take dispersion phase is solid, dispersion medium is also solid. Now, remember here, when you are calling solid sol, this dispersion medium should be in solid. The dispersion medium should be in the solid actually. And let me take example here, gemstones, isn't it? These gemstones are best example, isn't it? We can easily observe this from dispersion phase, dispersion medium. So this is a colloid actually. Gemstones actually comes under colored glasses. Whatever the colored glass you observe, no, they comes under what? This solid and solid. Next, if you observe solid and liquid, solid liquid colloid can be called sol, because when you liquid is a solvent, that means dispersion medium, you have to call that one sol, right? Now, best example, the blood can be taken as the best example for this one. The blood can be taken as very good example for this one. And the paints, whatever the paints, because in which what happened, the solvent is what oil, and the pigment is what actually dispersion phase. The pigment is what dispersion phase, and dispersion medium is what oil actually, isn't it? Even blood also same thing. Water will be dispersion medium, and whatever the pigment we are getting, hemoglobin, that should be what hemoglobin will be what now dispersion phase actually, and water will be dispersion medium. When you mix these two, what happen? It convert into blood. Blood is also what a type of colloid, solid liquid. Next, you see what solid gas here, in which always remember dispersion medium will be large quantity when you compare with dispersion phase. So gas is large quantity and the solid is less quantity. So in that case, solid in gas, it can be called solid aerosol. Whenever if you get aerosol, aerosol means dispersion medium is what? In gaseous state. When you get aerosol, that means what? Dispersion medium is in gas state. Now, what type of examples we can take? Dust particles in air. The dust in solid phase and air is in the form of gas phase. Smoke particles in air can be taken as what? Examples. Next, if you take what? Liquid solid. Dispersion phase liquid, dispersion medium is solid. Again, it is called now gel. Here it is called gel. Gel is an example actually. Gel is an example, isn't it? You can take butter, isn't it? Next, what happened? Gel is all comes in butter, gel, in which solid phase will be more when you compare with what? Liquid phase. Fat content will be more when you compare with water content in this case. Fat content is more in this case. And we compare with water here. Liquid, whenever this is very important. Emulsions are very, very important. What is the definition of emulsion? Emulsion means nothing but when dispersion phase is liquid and dispersion medium is liquid, in that case, that colloid solution is called what? Emulsion. What is emulsion? Dispersion phase liquid, dispersion medium is also liquid. In that case, the colloid solution is called emulsion solution. Example, you can take what? Milk, hair cream, you can take this one. Milk and hair cream you can take, in which both are what? Liquid phase only. But you can separate easily. That is the main thing you have to see. Liquid gas. Dispersion phase liquid, dispersion medium is gas. So this will be liquid aerosol, in which dispersion medium is gas, liquid aerosol it is. Now best examples we can take fog. Fog is what? Best example, in which fog actually water droplets present in the air. So water droplets will be liquid state, so liquid in gas. So fog is best example, and insecticide spray also if you observe, Insecticide spray also contains liquid in gas type of colloids here. And even clouds are best example here. Cloud contains water only actually, isn't it? Doesn't where in the it's gas in solid. Gas in solid is. So this is example we can take. Rare examples will be there. Better. Foam, rubber we can call. Okay, foam, rubber or fumized stone. Fumized stone is a rare stone, and this fumized stone will float on the water. This will floats on the water actually. Float on water. Okay, because of the small holes, what happened? Definitely, what happened? It is a solid, but small holes. In that small holes, gas will be there. In that small holes are occupied by the gas. So that is the reason what happened. It will float on the water. So milestones we can take best example. It's gas liquid collides foam. Gas liquid can take foam. Example: Viper cream and froth also we can take. In cup of tea, whatever the froth we are going to get. Froth means what happened? Lather. Lather we are going to get here, isn't it? That froth can be taken as what? Gas in liquid. Because in cup of tea, when you take cup of tea, what happened? That whatever that froth, in which phase actually? Gas phase. And the remaining tea is in which phase? Liquid phase. Therefore, gas in liquid. So foam, one of the best example. Gas and gas you can't take. The ninth one you can't take better. Gas and gas cannot be taken as a colloid. So if you get a question like this, why gas and gas cannot be called as a colloid? Because gas and gas is a homogeneous mixture. The answer must be how to give the homogeneous mixture. Gas and gas is a homogeneous mixture. Therefore, it cannot be called colloid. Homogeneous mixtures are called solutions, but not colloids. So this is actually what the classification, which is based on what the physical state of dispersion phase and the dispersion medium, right? Many familiar commercial products and natural products like creams, milk, dust. There are a number of products for there. So without colloids, what happened? There is no food. Most of the food, for example, you observe what are milk, cream, fruits, isn't it? They are nothing but what? Colloids. So atmosphere, if you observe dust, isn't it? Clouds. The atmosphere is made up by what? Colloids only. Paints are nothing but colloids. So whatever the everyday life, if you observe what happened, colloids are very, very important. Proteins actually, which are actually in colloidal cell particles. Now, this is very important for us. Whenever dispersion medium is water, whenever dispersion medium, if it is water, okay, then that is called aquasol or hydrosol. We call hydrosol. Whenever dispersion medium is water, then you have to call aquasol and hydrosol. Whenever dispersion medium is alcohol, you have to call alkosol. If it is water, aquasol. If it is alcohol, alkosol. Butter is an example of what? Butter is best example of what? Gel only, because the solid content is more known. Therefore, it is a gel. How is an example for what? Liquid in what? Liquid in gas. So you can take what? Liquid aerosol it is. It's about the classification based upon the physical state here. The next is what? Lyophilic and lyophobic colloids.